Another misconception about evolution by natural selection is this idea that evolution perfects organisms. So evolution does not perfect organisms. It does select individuals that are best suited for their environment, but it can never make them absolutely perfect. And so vestigial traits are a great example of that. We talked about kiwis having these little wing nubs. Those wing nubs don't really serve a purpose, but they stick around. There's also genetic constraints. Okay, so the idea here is that we can't just have any trait we want at any time. So you could imagine that it might be ideal if humans could photosynthesize so that you didn't have to eat food at all and you could just sit in the sun and get all the nutrients you need. But there's genetic constraints on the ability of humans to produce chloroplasts and do all the things that they needed to do photosynthesis. So this is a silly example, but the point here is there's always constraints on how perfect an organism can be based on the amount of genetic variation that exists within that species. On top of that, there's trade-offs. So trade-offs is just simply the idea that any trait that you have, there's a cost that's associated with that trait. So you can think of as giraffe having, it being advantageous for a giraffe to have a long neck for some reasons, but it's also a huge disadvantage to have a long neck. As you can see here in this picture, when it's got to bend over to drink, it's sometimes got to do the splits just to reach the water. So costs come at all adaptations come at a cost. Not everything is perfect for all situations and all scenarios. And that is to say that fitness depends on the environment. So this is once again a sort of silly example, but if we think about this guy Gortat, who's 7'5", in the context of basketball, that's a great trait to have. It's wonderful to be tall. It's super advantageous. But if you put him in a car, it's a whole nother issue, right? So he's got to have giant cars, and there's probably a ton of other situations where being that tall puts him at a huge disadvantage. So fitness is always context dependent, and evolution is never going to make an organism perfect for every single situation and context. Other misconceptions: selective pressures cause organisms to adapt. So this is a false statement. So going back to this bluebill example, just remember that the predator coming along didn't cause dots to turn blue. It only selected from the variation that was already in the population. Okay, so the predator coming along didn't cause a mutation to occur. It didn't cause organisms to change. It only selected from the variants that were already in the population. So selective pressures don't cause organisms to have mutations. They don't cause them to adapt. They only select from what's in the environment. Another misconception is that natural selection is a random process, okay? So natural selection is not a random process. So mutation is a random process. Mutations happen randomly in the background, but natural selection is a non-random process that will take whatever those random mutations are and select from the best of them for that particular environment in that particular context. So although mutation is random and it's occurring randomly in the background, selection is not random in the individuals that survive and reproduce. So just like the bluebill example, those blue dots were selected because they were blue for and they blended in very well with the environment. And so those individuals that survived were not random. They were very specific individuals with a very specific trait. So natural selection is not random. Another important misconception is this idea that individuals evolve. So individuals do not evolve, populations evolve. So individual organisms can acclimate or adjust. So for example, Crazy Tan Lady can adjust to her environment by getting a tan, or Arnold Schwarzenegger can adjust by getting super fit. And this is an example of acclimation to your environment. Okay, so an individual can sort of change their morphological appearance to adjust to their environment. But this is not an adaptation because that trait is not heritable. So Crazy Tan Lady is not going to have crazy tan offspring. Arnold Schwarzenegger, this is his son over here on the right side, is not going to have a crazy muscular baby, right? Those individuals might have the ability to get fit or the ability to get a good tan, but those traits are not passed on to the offspring. Okay, so acclimation is different from adaptation in the sense that those traits are not heritable and individuals don't evolve. It's populations that evolve. And they evolve over generations, okay? So it's bad to think about This idea that one day there was a lizard with legs and its legs popped off and then you had a snake. No, you have this slow sort of change over many, many generations, and it's the individuals in a population, the percentage of individuals in a population that change over time. And that change in the sort of frequency of individuals in a population over time, that is this process of evolution. So it's populations that evolve over generations, not individual organisms evolving. Another important misconception is this idea that natural selection is evolution. Okay, so natural selection and evolution are two separate things. Natural selection is a process, and evolution is the outcome of that process. So it's important that you make the distinction between those two things. So natural selection weeded out the red and purple individuals from the population, resulting in blue individuals in Blueville. And so this population has evolved as a result of natural selection. And there's, in fact, many other processes besides natural selection that can cause a population to evolve, and we'll discuss some of those other processes. So natural selection is just one process that can result in evolution. Another important misconception is the idea that in evolution, only the strong survive. So this is also a false statement. So a sort of concrete example of this is female mimicry in salmon. So what you're looking at here is a large aggressive male salmon that's very good at fighting off other large aggressive male salmons from the opportunity to breed with a female salmon. But there's also female mimic salmon. And so here what you're looking at is a female salmon, and below is a female mimic salmon. And so this is actually a male fish that looks just like a female salmon. And so these male fish obviously are not the strongest fish out there, but what they're able to do is sneak past those strong males because they don't realize that they're males. And they're actually very successful at breeding despite not being the strongest individual. And so just because you're not the strongest individual doesn't mean you're not the most fit. You can have fitness without being the strongest. And so this idea only the strong survive is a misconception. And these female mimic salmon males are a great representation of why that idea is incorrect. One last misconception is the idea that some traits are too complex to evolve. And an argument that's often made sort of under the same vein is, what good is half an eye? So how do you have a trait as complex as an eye that has a lens, an iris, it's filled with fluid, it has all of these sort of receptors in the back of it? How do you have a trait that's that complex evolve from nothing? But the problem with that assumption is that it assumes that we started with nothing, when in fact, if you look at the evolution of the eye, at least within mollusks, you can see that we have these sort of transition states where we start with something as simple as a patch of light-sensitive cells transitioning into an eye cup, into a sort of simple pinhole eye, and then an eye with a primitive lens, and then a complex camera-type eye that's similar to the type of eye that humans have, with a lens, a cornea, an optic nerve, a retina, all of these things. And so an eye didn't just magically appear from nothing that could ever sense light at all. It was this slow process over millions of years and modifications to this sort of simple patch of light-sensitive cells that led to the evolution of an eye. And so complex adaptations can actually evolve from simple ones in a series of small steps. These complex adaptations don't just pop up out of nowhere.